One thing that you would need to do is assign formal charge. Formal charge is a big portion of drawing organic structures, and it's also useful in predicting somewhat reactivity-wise, especially when we deal with mechanisms in mechanisms next month. So, there are two ways of assigning formal charge. First of all is the official way. What you do is you count the number of electrons, but when you're counting number of electrons, it's different from when you count in terms of octet. When you count the number of electrons, what you're doing is lone pairs they count as 2 electrons because, well, each of those lone pairs has 2 electrons in it. Bonds, though, they count as 1 electron. Now, this is different from octet counting. Have to keep that in mind. So, once you have that count, what you do then is go back to a periodic table and find out which column, which family the element is in. So let's take a look at this molecule right here, H3O. Hydrogen is in group 1. I'm going to draw in 1. And it has 1 bond. And so what we're going to do is subtract that 1 electron from that 1 bond, and we get 0. That's the formal charge of the hydrogen. Let's take a look at the oxygen. That oxygen is in group 6. Now we're going to subtract the number of electrons that oxygen has. In this case, that oxygen has 1, 2, 3 electrons from the bonds and 2 electrons from the lone pair. 6 minus 5 gives you 1. The formal charge on that oxygen is positive. Let's take a look at this nitrogen. This nitrogen is in group 5. It has 2 electrons from bonds and 4 electrons from lone pairs. We get 5 minus 6 equals minus 1. This has a formal charge of minus 1. Okay. Now, that's the slow way of doing things. What you need to be able to do is the fast way. What I mean by fast way is look at the periodic table and renumber the periodic table. We'll start at hydrogen as 1, 2, 3, 4. Then once we get to 4, we're going to start counting down. 3, 2, 1. These red numbers right up here represent the number of bonds that these elements have in order to be neutral. Take a look at this oxygen. This oxygen has 3 bonds to it. That's 1 less, that's 1 bond more than oxygen normally has. So 3 bonds, when it's only supposed to have 2, positively charged. Nitrogen, 2 bonds, when it's supposed to have 3, negative. What you should be able to get to the point is whenever you see an oxygen with 3 bonds to it, you should automatically think of that oxygen as positive. If you have an oxygen with 1 bond to it, such as hydroxide, you should think of that as negative. It should become second nature when you draw these structures to draw the formal charges in. Oxygen with 3 bonds, positive. Oxygen with 1 bond, negative. Nitrogen with 2 bonds, negative. Nitrogen with 4 bonds, positive. Boron and aluminum, they each form 3 bonds. When you have 1 bond extra, when they form 4 bonds, they become negative. That should also be second nature. Whenever you draw a boron with 4 bonds, negative. Aluminum, 4 bonds, negative. It's also possible to have the carbon with formal charges. Carbon with formal charges will usually appear if you have a lone pair on a carbon, such as right here. This carbon right here has 3 bonds to it. So that's 3 electrons, plus the lone pair. That's 5. That's its electron count. Carbon is in group 4. 4 minus 5 equals minus 1. So if a carbon with 3 bonds and a lone pair has a negative formal charge, much like this carbon right here. The reason formal charge is really important, especially on carbon, is this molecule right here. This is a positively charged carbon, carbocation. If you omit that positive charge, you get this molecule right here. Which is 2-methylpropane. Because when you don't have a formal charge there, that implies you have a hydrogen present. Huge amount of difference between this and this. This, not stable, very reactive. This, stable. Huge amount of difference between those two molecules.